let's have this session very interactive one. Hi, I'm Jagadish. I'm a delivery consultant in AWS, working in AWS professional services. I'm a delivery consultant. I work with different customers to migrate their databases from on-prem to cloud. And to start about myself, I would say I have started the Postgres journey when Postgres was 8.4. That's like 2011, wherein I was working in NIC, National Informatics Center. I think people might have heard about it, wherein we used to maintain the driving licenses of whole India, and I used to manage the databases. But yeah, it was a journey where it started with the Postgres 8.4, and I have seen the whole journey of 8.4 to 18. So I'm fortunate that I can speak about 18 now. So that's how it is. I work for different companies in Amazon for more than 7.5 years now. And usually I am a developer come databases, but now I'm being mostly on the migrations part. But I do love to explore the Postgres, how it is, what are the new versions coming in. I'm a big brand ambassador of open source Postgres. And also, I think for the meetup, right, to be very frank, I was there when it was 2013-14, where 3-4 people from Hyderabad, Baji, me, Rajesh, Anurag, Bhaskar, kind of 5-4-6 people, we started the meetup using the meetup channels. Collaborating it was a nice journey. I think it's very fortunate that I could see these many faces. It was not there at that time, and been attending different sessions and all. So yeah, I think I'm boring much. So let's start. Postgres 18, right? So when we say Postgres 18, I would say Postgres 18 is like going from a reliable sedan model to a Tesla now. It's getting better performances, smarter automations, and way more visibility into what's happening under the hood. It has improved a lot. So I would like to have a quick question. So how many of you have written analytical queries that scan millions of unnecessary indexes entries or waited minutes for vacuums? I know the pain points. Yes. So we are today. I think so. Today we are going to try to dive deep into Postgres 18 performance revolutions. What it has bring in. I would like to actually do the demo, but based on the time constraint, let's see if we can do that. I'll not bore you with more of the slides and the theories, but yeah, I am going to take some time to show some numbers also. And see, because in my test environments, I could see a 10%, 20% improvements in the queries. The vacuum process has improved much more. Like I could see vacuum process got improved like 200% also. But these are all my benchmark numbers based on your scenarios, your customer use cases. I would recommend strongly to test it in your environment and start the testing. Okay, let's. The agenda would be simple. There are multiple new features in Postgres 18. I think Postgres community has grown bigger and bigger now. We are seeing, that's why we are seeing lot many patches, lot many features in every new versions. I would like one-liners are new features, and then we'll jump into the performance features, which I am concentrating. That would be the B-tree skip cans, the vacuum performance, and the enhanced where clause processing. So this is basically a kind of a development stuff, and also I would cover this vacuum process and all. I would cover some of the data DBA guys issues. But yeah, I would like to cover only these 3 topics for now. I'll quickly jump into these. The new features, there are a lot. There's a big list. I can share the public URL. I forgot to, wherein you would see the asynchronous I/O subsystems. So I'll keep it really short. So usually in Postgres, so when you say I/O, right? So it's going to the disk and getting it. So what happens? It is async, right? It is in async mode. Sorry, it's in sync mode. So what happens? When you write a query, it will go to the disk and it will fetch for you, right? So now, sorry. So Postgres has now added a parameter called IO method, which you can change in the configuration parameter, where there are 3 options: sync, worker, IO. wherein it would not actually go into the disk every time. It will pick it up from, like, it will actually create new IO workers. I'll quickly show that in one of the demo part. I'll quickly run that. Like, if you see, if you install PostgreSQL and you just say ps -f grep Postgres, there are, like, I think 8 workers, like PG background, writer and all. Now you would see IO worker process also. So that would kick in the process of, it would actually allocate an extra IO, and then it will speed up your queries. So that's one. PG upgrade, now retain optimizer statistics. This is because when you upgrade it, right, so your stats are gone. But with this feature, you can have your statistics also. I have not tested it, but would love to do that. And also, these all features, I'm trying to still get all the numbers and all the stats for this new features, still in learning path. So that's what. So UID 7, there are multiple blogs, documents. I think I'm seeing multiple blogs from open source DB team also on each and every features. So yeah, let's see how these features are getting value added. And you won't have much blogs or videos around those. So I would say recommend all the guys here, because we are all in open source database, we are using it. So I would say please test this, because it's an open source database. Try to explore, try to blog it, try to write some patterns, papers on it. That would help other developers and the DBAs to get these recommendations or the learnings from what you guys are facing. There's something called OAuth authentication. I think most of the enterprises are now using Okta. So that's where I think these PostgreSQL 18 is supporting the Okta and some other authentication methods. And also I would say, I have not added it here, but I think down the lane MD5 authentication going to be deprecated. So let's see how fancy things going to be with the Postgres now going forward. And these old and new support for returning clauses and the merge commands. Merge commands have improved a lot, because if you as a developer would have seen, right, whenever you merge or you update things, there is always an old and new records, and every time somebody would be asking, hey, where is my old record? Can I capture something there? So, there are some changes there, and certainly you can test it and get some insights on it. I'm not trying to cover it because I'm not a big fan of merge commands. It's very tidy. So yeah, that's one. And also these temporal constants on the primary keys, unique and the foreign keys, things have changed. So I would say, please go ahead and test it. So in my agenda, I know I'm like, after 5 minutes, I'm getting into my concepts here. This is B-tree skip scan. This is one of the future one, right? It's optimization techniques that allows Postgres to efficiently query the composite indexes. So no fancy English, I would say. When you have one table with 4 indexes, it would actually skip the index, which is not needed. So let's say you have one index and you have one B-tree, like I would say, how would I say? So let's say if you have 10,000 records and you have one index, one B-tree, the block is like 100 records. The second one is 101 to 200, and then it's like that way. So this is intelligent enough. Now the algorithms have changed that it will directly jump into the B-tree, the node where it is actually getting the records. I'll show you that in some demos down the lane, but to cover on a top level, right? So it is actually going to skip which is not needed, and then it's going to help in getting the queries output in a very efficient way, right? And also automatic optimization detection, IO reductions. As I said, IO reductions, because it is not, because these IO workers and all, it's going to help to not go actually to the disk and get it from, and so there are multiple IO workers getting in place and getting the output right in time, I would say, with much better performances. And to all these features are all by default. You don't have to do anything. You don't have to change all the configurations. It's very simple. I know I'm going a bit fast here because I wanted to capture more on the queries and the SQL analyst stuff. Here also some screenshots around wherein if you see here, right, you could see that there are indexes only also. But if you see here, the buffered shade, if people are able to see now, so buffered shade hit is 6 here, that's a 10 here, right? But the execution time has been better because there are parallel IO workers who's going to work out in the background, and also it's going to skip. So let's say, for example, right, this product ID, which is like, and the condition is more than 10,000 and less than 15,000. So there might be like more than 100 indexes, but still like it's not 100 indexes, one index, but multiple blocks. It's going to skip few of them and it's going to get the records in much better time. The planning time has improved because it's going to take a bit of extra time on the planning time, but the execution would be much more faster in PostgreSQL is what I have observed. I would say please try to test it also here in your whole use cases. This is my PG16, and also if you see here, right? So this index blocks read is 0, index blocks hits is 3000, right? But in PostgreSQL, you would see that the index blocks hits is 336. It's actually trimming the whole theory of getting the index, like getting the right data from the right index. So that's the whole theory beyond the about the B-tree skip scan. So yeah, this is how it is. I'll show them in the slides or in the queries. Any questions till now? I would happy to take it. Okay. But I would say these are all like learn and get the confidence, because theory can be much more, but if you actually play with your numbers, it would be really nice. Let's go back to the vacuum. So now let's tackle everyone's favorite topic, right? It's a vacuum. In these vacuum features, right? So basically, I think everybody know that when we have these MVCC architecture, when it maintains a different version and it is marked for deletes and all, what has came in this with the 18 is, it is actually efficiently deleting the dead tuples. Like it is actually, it would say, if you have deleted the batch of records in one block, it is actually very efficient in getting these details and deleting those tuples. It's very efficient is what I have tested. But yeah, I think I'll try to see if I can share the scripts and I can get the screenshot, not the screenshots, I can show the live example here. Reduce bloat in frequency updated tables. For vacuum, I have a really good case, but yeah, for the reduced bloat in frequency updated tables, right? So what happens in the reduced bloat in frequency, it is actually going very aggressively about the bloats deletions. So it is very aggressive. So I would say in this, what do you say, in this vacuum process, what is happening is on a top level in PostgreSQL. So let's say if some table is really heavy transactional OLTP database, and if you have 1 million records, I'll jump back to that part. Yeah, here. So what I have tested is I have 10 million records on a table, and every second I have 1000 updates, and it's a 24 operation table. I have created five indexes. I'll show them, not this part, but the queries what I've used. So usually what happens, so when you have a table and these are heavy transactional tables, based on your scale factors and other factors, it used to take like 45 minutes to actually do that vacuum, right? But what has improved now because of all the algorithmic changes in the vacuum process or the IO disk and all the different components, it is now actually, it is not vacuuming the whole table. It is actually for, I would say, 18 minutes or 15 minutes, it's vacuuming it. Whatever the percentage of vacuum is done. The other 60% or 40%, it's going to do it later when we have all the available process. So this is how it is. You get an improvement. So if you say one table which had like a big table and like these many records, so every 45 minutes, like after every 6 hours, it's going to kick in those vacuum process. Now what, and it is waiting for like 45 minutes and getting all these exclusive logs to get this finish up. And because of this vacuum process, all your resources are like piled up, your queries are not getting the memories and the disk. What has improved now is it is not doing the whole vacuum on one table right away. It's going to do some chunk. Later again it's going to chunk. So later it's going to chunk. So that's where you would get the benefit of more than like, what do you say, 180 minutes per day. Like you would have all the resources available to your queries because of this change. Any questions? I think there would be questions. I'll go back to the queries and I'll explain much on those parts. So yeah, here I mentioned, right? I was testing with these 50K records, these vacuum tables, these live tables, dead tables. I did a heavy update. So this is what it is. And the vacuum, you would see a 5 millisecond performance benefit, but This is on a very small table, like not a very small table, but yeah, this is on a one single table. But on a heavy transactional million records also I have tested. But that's for one of the scenario I was testing for one of the customer. I could get more than 150% vacuum benefit is what I have observed. So that's one part. So here if you see, right, the dead tuple ratios, here it is 25% only, but here that's 35%. But still, I could see that the benefit what I got from the vacuum process, it has improved. And I would say everything is not tested with the multiple numbers like the scale factors, the vacuum thresholds, and the percentages. It was not tested. I have tested it pretty much basic, what the default configuration have came in. These are my numbers. I'll also show in some of the demos. 1 second, I think I skipped one. Okay, yeah. So this is more of a theory. What is happening is a better tuple ID tracking, more efficient data structure for tracking dead tuples, right? So here it is marking something in the background wherein it is like saying that it is intelligent enough that these are my dead tables in the database. And optimized index cleanup, these are like skips index spaces that don't contain dead tuple references. So as I said, right, because of these bitmap scans and all that stuff, it is actually skipping the indices which does not. Let's say if there is like 1 million record, you have 10,000 records sitting in one block, and the other block has like 10,000 records which are marked as delete. I think that's going to be picked up and that's going to be vacuumed. That's how it is going to be. Because of parallel processing, you get a benefit of these multiple CPU cores. It is doing very well at like IO levels for sure. So yeah, because you have a faster vacuum, more frequent cleanups is done. And as I was calling out, right? So for every 18 minutes, it's going to run, and it would improve the performances. And these are very, very theoretical in nature. Improved automatic triggering. These are all from the algorithms what they have. I don't know how that was done. How these magicians have came in with those the Postgres developers with all these concepts. They're really exciting. I'm still trying to understand how these are done in the backend. Yeah, I think down the lane 2026 it would be the year wherein we should have all the meetup sessions for sure for Postgres 18 because we do have all the good things happening in Postgres 18. Better concurrency during vacuum operations, shorter log durations, as I was calling out earlier, because it is doing it very shorter log durations. Like it is, if the table in your scenarios, if in 16 or 15, if it's taking 40 minutes to finish the vacuum, now it's going to do 15 minutes and it's going to wait for some more other time, and then when based on the resources, it's going to do it later. That's like what the thing is, and because we have the locking things are optimized. Now, sorry. Where am I? Sorry, here, yeah. No. Yeah. So, parallel cross. Yeah, and you have better concurrency during vacuum operations because of the shorter log durations, better log managements, and improved buffer managements. There are multiple parameters to it, but I think still you can play around with these options. But what I have observed is these. This is the performance benefits what you are getting in the vacuums. Any questions in the vacuum? There would be. I understand, but yeah, we'll take it later. And if the audience around are developers, I think what the basic questions would be: my queries are performing bad. What's happening with my where clauses and the in clauses or the or clauses? I think Postgres did an awesome job in improving these performances in our concepts and also on the merges and all of the stuff. So what's happening in this is in this improved OR handling. So one case is if you have one query and there is on conditions wherein it is comparing with the in clause. Now the things have changed wherein it is actually doing it in an array. So when you are breaking the data into an arrays, it's much better it is performing better, and also the outputs are coming in really fast. I would show one query and how it's performing. So yeah, that's how it is. And query planner also got smarter, as I said, because of all these architectural changes at a very disk level, IO levels. These planners are also getting smarter and got smarter, and queries are really performing well, is what I have observed. So as I was calling out, right, so improved OR handling and the enhanced in clause, and also the query planner. So in the improved OR handling, efficient bitmap storage is being used. Smart memory allocations, adaptive size based on the selectivity, because if the the memory allocations has to be done in a right way, so that's being managed in a very new and different way. Buffer coordinations minimizes cache pollutions. This is all features which are coming in with the improved OR handling. This you would see in the queries where you have a bitmap OR and how these are being skipped and how they are being handled. Enhanced. So in these, like in the in-clause processing, where we have parallel index lookups for multiple values, efficient range operations when beneficial. These are, I would say, these where clauses and the in-OR bitmaps issues, they are very much valuable if you're playing with a very huge data sets and kind of a hierarchical databases or a time series databases. It is really efficient in those. We have tested it. If you see here, right? So enhanced in-clause processing. What I have observed is in the small list, if it is going for sequential scans, but if you play with million records or more than 100 values, like those kind of bigger tables, I would see that it is actually improved a lot better, is what I've observed. So that's in clause processing. If where you say you have in conditions, multiple conditions, like for example, one region has in south, west, north, south. Then if you have an in condition, these queries have performed well in 18. That's it. Okay, I think we have the time. So let's go to the demo. For us, I think I have, I'll quickly connect to my screen. You guys can see my screen? No? Or still in PowerPoint? It's not. 1 second. It's only one slide. 1 second. Let me see. One second. Going back to the terminal. I'm just trying to see. No, I am not going. 1 second. Can you go back to the terminal, please? Terminal?
Yeah, the terminal.
It's not. Yeah, I'm not.
Oh, just presenting only that.
Yeah. No, but I haven't connected. Just the HDMI. Yeah, it is coming there. No, it's not visible.
I think you have set a, what's that? It's opacity levels. Just a moment. Okay, item 2. General.
Yeah. You want to change the tab or something? No.
There is search option.
No.
Do you see any opacity levels?
I don't see it here. Terminal is not showing up. Any questions still now? Or maybe if you have any. Meanwhile, terminal is not showing up.
You have to drag this, right?
Oh, that's. Oh, okay.
Oh, you
Okay. Okay. Oh, that's a multi-screen. I understand. Okay. Okay. Problem. Okay. Got it. Sorry. Okay. 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 The cursor is here. Let me go back. Yes. Okay. Then I will go back to this mode. You guys can hear me loud and clear, right? So. Okay, yeah. So this is my Ubuntu machine which I'm playing with. Yeah, 1 second. Is it okay now? Okay, done. Okay, this is one of the EC2 instance, and this is I'm playing with. This is my Postgres. I'll say PSQL minus P 5432. This is my D PostgreSQL. Yes, select version. Just to give you some context that I'm still playing with. That's on Ubuntu 18. And that's on Ubuntu 13. My Postgres compiled code is Postgres 18.1. Okay, so I have one database. I have only 3 to 4 tables, one for each one. This vacuum test and demo tables are different things. But before that, maybe what I can show is I was very cautious that maybe if I'm not going to have internet and all that, so I have generated few test files. Okay, I'll quickly show them. Okay, you see many queries. So I'm going to cover mostly on these are like the B-tree skip texts. This is PG18 stuff. This is vacuum stuff. This is the where class stuff. These are all the SQLs which I was playing with. I'll quickly show the SQL files. These are my execution files. I'm going to compare and show it to them, like how it's going to be looking into. Yeah, I'll go back to 1 second. Okay. PG Hyderabad. Okay, I think that also I have to drag. Okay, not here. Yes. Okay. So these are my files. This is Postgres 16 on the B tree. So what I'm trying to do here is I have created a table called skip scan demo. I have a table. I have these insert statement. What I'm trying to generate with all this, like a region wherein north, south, east, west. I have the products. I have the product IDs. And what else? The categories and the price and the creation date. That's very simple. The current date. So this is how I have generated the data. Yes. Oh, sorry. So yeah, this is how I have generated the data. Hello. It is on. Yes. Okay. Sorry. So this is how I have generated the data. That's what, like I was said, right? This is not a customer use case. This is not. This is all sample data which I was trying to populate and I was trying to play around. This is one table with these many records. This I have created. I've analyzed the table. I have created only one index. Okay, and this is all about the explanation how this is. Let's say if I can insert. Let me just reset the statistic. Oh, sorry. Okay, it's too big for me. Okay, because I'm very close to that. Okay. So I ran these queries. So this is a select distinct, the explain buffers. I'm trying to get all the region and the product IDs with the product ID less than 1,000. So this I'm going to show that report to you. So if you see here, right? So the group by pass, these queries have these are all on 16. I'll compare the numbers and show it to you. So this is what I'm trying to do here. I'm trying to get these the group bys and the min and max parts in these regions. These queries have performed good in Postgres 16. They are good, and also in Postgres 18, they got a better performance. These are the same queries on both the versions. I'll quickly share the outputs. So if you want, I can run. If you want, yeah, I can do that certainly. Please raise any questions if you have. It's okay. Which one?
Column by column.
Okay. It's okay. I think parallel. It's okay. Parallel.
Is it okay?
Yeah, no problem. ఇది అవునా ఇప్పుడు మళ్ళీ కష్టం వద్దు పర్లేదు ఇట్స్ ఓకే అయిపోతుంది okay let's I'm going to run this everything so it's going to drop everything and this is how it is minus f this is 01 b3 scan PG18 I'm on 18 yes yeah this is 18 it's going to drop all the tables and run it again yeah it is creating it it is doing it it is doing it it is doing it meanwhile we go back to the 16 one I think something changed okay again command plus plus yeah okay am I audible guys like I still have anything clear okay and this is my laptop from where I'm sure okay better now yeah simple this is PG16 this is running on my 45433 same EC2 instance using it for both the testing this is on 16 yeah sorry yeah okay let's select version just making sure I'm on the right 16 yes so I'm going to quickly run the same file here as well minus d 5433 yes minus f 01 b316.sql okay now if you go back okay now we'll see now let's observe the 16th one first this is where it started yeah so I've as you've observed like I've dropped the table created the table inserted these many records created indexes setup complete the behavior usual traditional behavior this is my analyze query it is going in for the sequential scan on the index sorry it's going on for the sequential scan and this is the buffer share hit radios read and writes IO timings these are planned timings I think everybody is aware about these explain analyze outputs what they are coming in the cost the actual times I think we had many sessions last time also on this vacuum the explain analyze so this is taking 19 seconds milliseconds in 16 hey, where am I okay sorry yeah it is going okay 1 second it has gone okay session has gone I think yeah okay there this is 18 it has gone okay let me show the numbers in the text files it's okay yeah this is 01 dot where is my txt files yeah this is the one dot 18 dot txt file yeah this is where it is I wanted to capture the screenshots and put it but it's good to have show them in the this way so results yeah this is started the file same step same table same something everything same hey sorry what I'm showing this is for skip scan yeah so this is my first query no yeah it's taking 6.39 milliseconds right here it was how much 19 seconds yeah so that's what like it has performance-wise, it has improved for sure. So I would say, please go back and test it. So if you see here, right, there's a lot things improved in this parallel sequential scans in the 16. But in here, results, I know I added much more. Yeah, this is the one. It got it in 4 seconds. And how much was this? This was in 15 seconds. Same table, same records, some maybe some changes in the random generations components. But I wanted actually to explain each and everything, but it's going to be too much. So maybe we can do a part 1 or part 2 series on this because it's a lot to explain everything here. And even I'm also in a learning phase where I'm trying to get most of it, how it is doing it in the backend. So that's the whole theory behind it. And also on the same part, the same B tree indexes, it's for everything the same. Do we have the time, Hari? 5 minutes, okay. So maybe I'll reserve that for maybe to take up few queries. If you want, I'm planning to put these observations and the SQL files in the public GitHub. Maybe we can have a chat around, and please try to touch base with me over LinkedIn or on phone. I'm happy to help. We can have these benchmark numbers compared, and I'll share these findings. We would explain more in detail. Love to happy to help for anyone. Yeah, that's all. Let's go back to the presentation. Yeah, that's demo is done. Okay, I think not done. Yeah, but it's like on the time constants here. Hey, where am I now? Ooh. Yeah, these are all my codes. Where's my cursor? So cursor is here. Okay, yeah. Yeah, go back again. Demo, that's it. And any questions? Yeah. Play from that side. Yeah, that's it from my end. Anything you want to add or anything you want to know? No questions? But I would say, to be very frank, I would recommend strongly everyone to test these features, these B tree stuff, these vacuum process, and also these in clause and the OR conditions. They're really helpful. Oh, sorry. They're very helpful in nature. I think everybody here, I could see their fresh faces started learning Postgres. Start with 16 and learn on 18. Test few queries, and also I would say take suggestions from your managers and put it in a place that, hey, I want this Postgres 18 to be installed somewhere on Linux or on Windows, and test it. And then you can convince your customers or the managers to move to Postgres 18 because it's really nice. I've seen, because it's very new, the first version was launched in May 2025, but I think the latest version 18.1 was in November 13th or 15th. So it's still new. Try to see and document things, capture, do make public GitHub links with your observations, with your use cases. That would help everyone to understand how it's going to work, what are your observations, what is the best use cases. Yeah, that's all I have. Still any open questions? Happy to take.
Vacuum, you mentioned 18 minutes or
25 milliseconds.
That is through auto schedule or manually?
I did it through manually. Yes. Okay, sorry, yes. So I think the question was, what I was showing here, right? It was like, in 16 it was taking 25 milliseconds, and in 18 it was taking 16 milliseconds. So was it automatic or the manual was the question? So, and has it really improved? But yeah, that was manually kicked in, and even manually kicking it is showing us the performance benefit. Even with the automate vacuum process, it has also improved in the backend. The algorithms have changed a bit, wherein the kicking of vacuums have not being very aggressive now, even with the multiple scale factor numbers and all. It would say your auto vacuum process is going to run in the background, but it's not going to block everything as it used to happen. Yeah, and as it used to happen, even it happens, but it is not that aggressive. It used to capture a lot many resources, IO levels and every stuff, but now it's a lot better is what I have observed. The memory part, the IO, the disk level components, it is actually giving back to the CPUs. So it is good. It's a nice process in vacuum now. Yeah, I think you had a question.
When it comes to the B2B scan, so is it launching the async workers just to fetch on the index or whether to fetch on the data specifically? Because in PG17, what we observed, because we are running a data warehouse on top of PG17. So in some cases where we have a huge set of data, the max storage workers to fetch the data, that is like creating a lot of it is eating up a lot of time. So we sometimes set it to 0 for something in a major table in order to update some of the major tables.
Yeah.
So like how does this?
Yeah. So I think the question was even with 15 version, right? You mentioned 17. Okay. So in the 17 versions, okay. Yeah. Maybe I'll not go back there. So so in the 17 version, I think the one have asked a question wherein. Even with the indexes or even with the loads, the queries were not performing very well.
Yes, it used to take a lot of time just to fetch the data.
Fetch the data, yes. Because even with the indexes, whether was it a composite index or a simple index?
It was a composite.
Yes. So what used to happen is, or even what in 17, what happens, even if you have a composite index, the cascading the cascading column is not going to be used in the previous versions. But the future now is that the cascading index is also going to be used. It's going to skip it and then let's go back. So if you have the first column has like 10,000 records and your second column have the records, same number of records, but it has the where condition what you're trying to see, it will actually make sense if you query the second one, but you cannot create an index again because it's again memory intensive. Again, what do you say? It's a disk usage. It's a burden on the system, right? But PostgreSQL now is intelligent enough to handle things wherein you don't have to create an index, but a composite index would help in getting a better performances. It's like cascading. That is why it's called B-tree skip can indexes. It's going to skip that and get the composite column, and it's going to use it to get the data for you. It's really nice. I would say test it for sure. Yeah. Any more questions? Yes.
With all this enhancement, what's the total resources?
I would say, so I'm a big fan of PG18, I think, but PG18, I would say on a personal note, right, because of lot many components got added, it kind of getting slow now, but a big fan of PG18, open source tools, and also PG Badger, that's open source. Yeah, these are the things, and usual DBS, query PS minus graph Postgres. It's a huge impact. It's not burden on the system, I would say. These IO workers are very helpful in nature, wherein it's giving you the right resources to execute those queries in a more efficient way. That's what I say.
Have we seen any significant change in the memory consumption?
No, that's what, like, it has improved for sure. I have seen that performance level. If you're running more than like 115 queries, 200 queries, what I have tested, I haven't showed it. These IO workers are giving much more better performance. Like these IO workers, because it's a process, right? Because Postgres, when you talk about, it's a process-oriented databases. It's going to kick in a process, and it's going to give you more allocations to the memories, and it's much faster, is what I feel. Sure.
You mentioned something about the index. So how is it different or same from the Oracle Exadata clusters smart scan?
I'm not an Oracle guy. I'm a SQL Server guy for sure. I migrated like terabytes of SQL Server databases to Postgres. I can help you that for sure. But Oracle, no. But I know few people who are around here. The guy standing there and Hari, they might help you in getting these comparison with respect to the Oracle. But yeah, if you want me to have a broader understanding on the SQL Server or Postgres, I'm happy to help. Yeah. Thanks a lot. Thanks for giving us this opportunity. Thanks, Hari, for organizing this. It's been great seeing these many people around these PG meetups. Thank you so much. Thank you, Entertain also.